Thank you for joining me for this very quick video. I am Mr. Ish. I hope you're all having a great day. We have to verify the de Moivre's formula for powers of complex numbers. You know this right here represents the de Moivre's theorem or formula where you're looking at a power of a complex number. Z to the power of n is equal to r to the power of n. Your modulus to the power of n and then the argument with the n applied. Cosine n theta plus I sine n theta. Right here you're looking at the Euler's identity or the Euler's theorem. How can you verify this formula is indeed true, the power of a complex number? Start here with a complex number. You know it's equal to your modulus times your argument, cosine theta plus I sine theta. But look at this right here. What is this equivalent to? It's equivalent to this, but it's equal to that. You're essentially saying z, your complex number, is equal to r times e to the I theta. That's what you're saying, and there's nothing wrong with saying that because it's true. Now bring in the power of a complex number is equal to r e to the I theta to the power of n. Now expand this part right here using algebra, laws of exponents, and the Euler's identity. You're looking at r to the n, and then you're looking at e to the I theta to the power of n. When you open this up, you're looking at r to the n, e to the I n theta. This n theta is nothing too scary because it's just like a theta being affected by a coefficient, the coefficient being n, but n also representing the power of the complex number. All you have to do is now expand this part right here and your verification procedure is completed. You have r to the n, you will have cosine n theta plus I sine n theta. This expansion being done by means of the Euler's identity. All of this is equal to z to the n, which is your power of a complex number, and the verification procedure is completed. That's all I wanted to show you. Thank you.